Thank you all for joining us, and welcome to a special presentation, Exec Track Talk. And I'm going to be welcoming a number of guests up on the stage with me today from HPE. We're going to give you guys a little bit of an education on the recently announced and launched RL300 ProLiant Gen11 platform from HPE. So let me get straight to the agenda. I'll first start out and I'm going to talk a little bit about our sustainability story and give you guys an introduction into the cloud native processors. And then I'm going to hand it off to Scarlet Gray, who will come up and talk about the RL300 and its features. And then we'll hand it off to Jean-Marie, because yes, this is an open platform. And so we want to have you guys understand what's going on with OpenBMC and the open firmware strategy there. And then finally, we will bring up Stefane to talk a little bit about his experience as a customer. Okay, so now a little bit about the cloud native processor and Ampere in general. This is kind of an overview slide for us. If you're curious about what a cloud native processor is, we coined the term several years ago, and essentially this is a processor that is first and foremost very, very power efficient and scale out. So it employs a lot of cores, and we employ them in such a way to essentially deliver very high performance for low power. And that is exemplified in the first chart here you see on the left. What we're showing here is a real world workload, Nginx in web services, very, very highly deployed application out there. And that we're showing here that we can essentially outperform the legacy x86 competition by up to 3.5 to 4x in some cases, especially if you look at the power efficiency, which is, of course, the total performance you get for a given power envelope. And if I move then to the next one, we're talking about consistency and predictability here. We're using Redis, which is a common memory caching layer in many web infrastructures. And what you're seeing here is the predictability of the performance under load. So we load the processor up near full utilization, and then we inject noise essentially in the form of a noisy neighbor. And that noisy neighbor is actually an x264 thread co-resident on the same processor or the same socket as the Redis. And what you see here is the Ultra Max, which is our 128 core part, is running very, very solidly at that high performance. Higher, of course, you can see in the graph than the x86 system to begin with, but what you see is that it drops out in the x86 system. When you turn on that noisy neighbor, the performance drops, and what's not shown on this graph is that the magnitude of that drop can be up to 50% performance loss during a noisy neighbor event. This actually happens a lot, and what it does is it trains the ecosystem essentially to never load their servers up more than about 50 to 60%. That is not cloud native, and we'll talk about that in a minute. X264 or H264 is the video services example here. It exemplifies, in this case, our scalability. Every time you turn on or you light up a thread or a process on one of our cores, you're going to get incrementally the same amount of performance out of that thread. And that is exactly not what a legacy x86 processor does. You'll see that a legacy x86 processor will tail off at the top end. Why? Because of frequency scaling and because of hyper-threading and a few other factors. But essentially, it doesn't perform linearly, and that's what you see out of the UltraMax processor here. Finally, that power efficiency, especially under load. So we chose Hadoop here to actually show this, this particular aspect of cloud native processing. Hadoop, a very common big data application for manipulating data at scale. And this is running a processor using Hadoop at 95 plus utilization. So we're essentially pegging the processor. And what I'm showing here is the usage power. So the gray bar, or the gray area under the curve, is the actual usage power during 95+% utilization. Some of you guys maybe who know server processor may be scratching your head going, that's crazy. because the TDP is in that red line right there. The TDP is the thermal design point. We're not anywhere near close to that. And that is a very, very common occurrence with the cloud-native processor. What you see is 40, sometimes even 50% better usage power than what you'll see at the thermal design limit. The legacy x86 processors actually run at that, especially at that kind of utilization, at or above their TDP. So that's not cloud-native. All right, we're going to move on. I kind of went through some of these characteristics of unsustainability versus a sustainable cloud-native approach, but just to kind of quickly run through them again. Utilization, we can run these things at low power, 100% utilized. That is cloud-native. On the other side of it, you're going to have to run it at 50 to 60% utilization, and you won't get anywhere near that linear scalability, and you won't get a very efficient profile. You can't actually pack your racks with servers in that case because they're so high power that you have to budget the rack. And I'll show you in a moment what this really looks like. So cloud native, you get that higher performance, we get linear scalability, we get a rack efficiency, and we have a low thermal load. This allows us to pack racks very, very densely and deliver a lot more performance for a certain power envelope for that maximum rack density. So this is what I'm talking about here. So in this particular example, we're choosing a 42U rack at 12.8 kilowatts. And instead of stranding rack capacity, because that 12.8 kilowatts here is the limiter, and I'm showing on the right in the performance graph common workloads. Again, some of the ones we just talked about, Redis, Nginx, X264, Cassandra, another caching layer, but very I/O intensive. And of course, SpecInt 2017, and I'm showing you the comparison against the legacy x86 ecosystem again of performance at the rack level. So we're scaling up, if you just imagine, if you will, that workload actually running at scale for a full rack. And you're going to get, again, 2.5, 3.5x better performance at the rack level. Another way to look at this is for equivalent performance, you can use 2 to 3x fewer racks. That is a massive value proposition. I want to make sure that you understand at the very bottom of this that I'm also comparing one socket Ampere UltraMax servers against 2-socket Intel and AMD servers. So this is disruptive kind of value proposition, very, very, very high performance for low power consumption. Now, my final slide, and I'm going to hand it over to Scarlet, is really looking at the overall ecosystem for software. We get a lot of questions about what runs on the ARM architecture in servers, and so we kind of got really proactive about this. We said, look, let's actually quit just saying, because this is a NASCAR slide, right? Everybody's got a logo slide. But it's not enough to show a logo slide. You actually need to be more proactive, and that's what we did. We went out and we started running applications on these servers, on services that deploy Ampere architecture. And we're running now today over 135 applications every day in and day out, not only in our labs, but in our customers' infrastructure. So when you go out to Google infrastructure or Microsoft infrastructure and Oracle infrastructure that is running Ampere, we're running it actively. And so we would definitely are always working on upgrading this and building the ecosystem through the community that we have through places like OCP and the Linux Foundation and the CNCF and all of the kinds of organizations that we work with to forward the software and ecosystem maturity around ARM processors. Of course, all of this runs on the brand new RL300, and I'm going to have Scarlet come up and talk to you about that.
Yeah, absolutely. Is my mic on? Perfect. Okay, hey everyone. So could not be more proud to talk to you all about the RL300 Gen11 today. So this is the first HPE Gen11 server. We're very excited to bring you that server partnering with Ampere. This is also the first HPE ARM-based system with a fully developed from the ground up ILO and firmware stack, also with the ability to enable OpenBMC, which I'll hand off to John Marie to tell you more about in a bit. But we're very excited to bring you this. This server is a single socket 1U design for cloud native workloads and tailored specifically to cloud service providers who are offering infrastructure, platform, software as a service to end users, digital service providers for content delivery, media streaming, social networks, other online services, and also digital-first enterprises who have adopted the cloud-native ecosystem and are scaling their e-commerce, financial, and other online services to their end users globally. And so all of this at a performance per price and performance per watt advantage. We're very excited about this single socket 1U server, first announced at Discover this year. And again, we will be shipping in November. This is the first HPE Gen11 server. Now, with this, we are bringing you more cores at less power consumption. As Sean let you know, we can scale that high core count while also utilizing less power. But it's not just about the amount of cores, even though that aligns very well with our target workloads here. It's also about the way that the processor behaves. And so we're able to bring you that predictable performance with single-threaded cores that have a constant frequency. And so you're able to get predictable, deterministic performance from that. And also, we wanted to give folks the strategic flexibility because we are bringing you this on the HPE ProLiant Foundation, utilizing Silicon Root of Trust for security with a very robust management system, but also enabling you to take advantage of OpenBMC for those who are ready to pursue and expand their open source strategy with a BMC platform. And so that's a fully secure transfer of ownership process. Now, extremely excited to share this with you all today. There are several units on the show floor. Please come visit our demo station in the back corner of the center over there. Happy to tell you more about the platform, share all the details with you. We're really thrilled to be partnering with Ampere in this effort and as we look to the roadmap ahead for what's next year. And so with that, I do want to let Jean-Marie go through the OpenBMC strategy for HPE and continue. So thanks, everyone.
Hi, thanks, Scarlet. A great platform couldn't hit the market without great software options. You might be hearing about OpenBMC at HPE since a couple of years. The main reason behind that is that HPE is still designing its own BMC ASICs, and porting OpenBMC to it has been a long journey. And we are getting closer and closer to reaching production level quality on these solutions. So the RN300 is the first server, the first ProLiant machines, which will be able to execute the ILO proprietary BMC software and OpenBMC on top of GXP. The solution that we put in place is to upstream all of our OpenBMC patches directly within the generic community-driven project, including the Linux kernel and the U-boot bootloaders and the OpenBMC software stack. We are probably the first OEM in the world to do that. So we do not want to enforce our customer to use an HPE-created image, but we will have the freedom to recompile your own OpenBMC stack and sign it. So there is something which is critical at HPE currently. This is the system security. And as you might be familiar, we have introduced within our Gen 10 generation platform a Silicon Root of Trust, which is allowing you to sign your your BMC software stack and ensuring the system security of the platform. So within OpenBMC, you will keep that capability up and running and being able to own the ownership of the platform by signing your BMC image with your own private key. So we call that process a transfer of ownership, and that is also why it took us so long to be able to enable OpenBMC on the ProLiant platform. We had to modify the hardware to enable that features, and the RN300 is today the first generation of platform to support that functionalities. There is also something which is key, is how do we scale OpenBMC support for our customers, and how do we quantify the various OpenBMC images that you might be willing to run on our ProLiant systems. And we designed specific tools to do that, which we call the continuous integration platform, which is available for free on the internet. You might be able to use it directly on the internet or replicate that software environment within your own productions. environments as a proprietary solutions. This is free software code that we give away to the Open Compute Foundation under the open source firmware work group. And this software stack is allowing you to recompile an OpenBMC image and execute it on the live production systems and get feedback about the quality of the code and being sure that there is no critical bugs like the fan controllers subsystems to ensure that the thermal response of the servers is properly set up. Just a quick comparison between what we had last year and what we are able to do with Gen 11. So Gen 10 Plus was a development platform. We were able to deliver OpenBMC image as a development platform to some specific customers, and the transfer of ownership was working in a one-way directions. With Gen 11, you would be able to install OpenBMC and reinstall IDLE, and that is something which is critical for the circular economy approach and sustainability, because we want to keep that capability. We are also offering a standard warranty on Gen 11 systems, so you are not losing your warranty solutions and services if you are switching to OpenBMC or switching back to IDLE, and that is something also critical for our customers. And what will be critical for Gen 11 is that you will need to have the capability to recompile OpenBMC by yourselves. So we are not going to provide you a created binary image. And that is something which is also important. And that is why you need to get in touch with our PMO office program, just to be sure that you understand not the complexity, but the requirements. So there won't be any impact on the circular economy model. So you will have the freedom to resell your Gen 11 systems without any issues and warranty loss. With that said, I'd like to welcome on stage Stéphane Dutil from Scaleway, and to discuss a little bit about who Scaleway is, what are their technology challenges, and how these challenges could be addressed by HPE and Ampere. So Stéphane.
Thanks for having me. So first of all, Scaleway. Scaleway is a multi-cloud service provider founded in 1999. We are mainly based in France, actually. We are running several data centers, 4 in France, 2 in the Netherlands, and 1 in Poland. We have a very complete ecosystem, cloud ecosystem. We are providing multi-AZ redundancy using native tools to manage those cloud environment. In France, mainly in France, we are trying, instead of creating new buildings, we are trying to reuse previously existing buildings and convert them into a data center. For instance, we have a former nuclear shelter, which is now a data bunker. A second example is a former postal distribution center. Mm-hmm. It reopened in 2018 as one of the most sustainable data centers in Europe. We are using adiabatic cooling mechanism or technology and hot containment. And so as of today, it achieves a PUE of 1.15, which is quite good for us. And also, we are trying to reduce the water consumption in this data center.
And what are the biggest technology challenges you face when you are integrating new server technology?
Well, the two main challenges, I would say, are the main manageability of the systems. Mm-hmm. First of all, we are the offering from the bare metal, virtualization, containerization, even serverless. We have a large amount of server in production. So we have to manage a large amount of server. That's the first point. Then we have a program, which is a recurring program, not a one-off project, to reuse a lot of servers, to give them a second life. We are trying to use the server for up to 10 years. For example, this year, we will reuse 14,000 servers, saving more than 7 tons of CO2 equivalent, just to make sure that all of these systems have a second life. Mm-hmm. Also, so that's a huge amount of machine, but also it's a lot of generation of firmware to manage all the hardware from multi-vendors. So that's one challenge. The second one is the energy, of course. With the current geopolitical context, it becomes very difficult. Even the access to the energy is a challenge. Mm-hmm. So we have to make sure that we have access to the energy, but also the cost of the energy becomes very very important in the cost. And so we are trying to make sure we are energy efficient. So, but also we have to make sure that the performance we give to our customer, we are a CSP, multi-cloud CSP, so we have to provide this level of performance to the customer, what they are expecting, what their needs are, how it fits their workload. And so we have to make sure that to find cost, energy, and performance efficiency in the data center.
Okay. And how do you expect, I would say, the joint offering that Ampere and HPE are working on to address these challenges?
Well, from our perspective, of course, the workload, the need of the customer is very important. But the choice of the CPU is a key differentiator. So, of course, even if at the right level, we have this constraint, as you mentioned earlier, we also have these constraints at the core density level, so at the chassis level. So it's good. I'm very happy to see companies taking care of this consideration, trying to find solution, and taking care of these kind of issues globally. From a manageability system, the issue we are seeing is that with all of this machine generation of hardware, it's a challenge every day to maintain, to monitor the telemetry, the hardware run, the maintenance of the system. And so we do expect that with this single stack, or with the open firmware stuff, we will be able to have maybe not one single image, but a very limited amount of image that we will be able to maintain and to make something more customable. We will be able to impact the way we are managing the power and the cooling in a more easily manner. So that's one of the option and the opportunity we see with these options.
Okay, thank you very much.
Thanks.
I thought this was super important to get this feedback from the European customers. So Sean and Scarlet, welcome back on stage.
Yeah, thank you.
And opening up the Q&A section.
We do actually have a little bit of time for some Q&A. I'll just pop this up so that you can see some of the partners at the show that have booths showing Ampere content. Of course, prominently shown here is the HPE booth, which is all RL300 this year.
Yeah.
But we will be happy to take questions. There are mics in the aisles, yeah.
Well, even with the mask, I think I could project.
Okay, yeah, you're doing well.
No, can you ask the question through the microphone? Because this is recorded. Thank you.
Okay, so I think you implied that the Ampere processor does not use dynamic voltage frequency scaling, but instead that every core runs at the same frequency and therefore presumably the same voltage. Is that correct?
Yes, that is correct.
Thank you.
And then maybe just a bit more on that. So the x86 ecosystem does do a lot of frequency scaling, and they do that on purpose. You know, back in the day, it's a good feature, right? Because there was a lot of a need to essentially tune to a workload. But as cloud has built, and as cloud native applications have built, it's become much more important that you get predictability out of microservices or even just highly interconnected macro services. So that is one of the reasons why we chose to design a processor from the ground up that was much more predictable, and that's one of the ways we've gotten it. Any other questions?
So do not hesitate to come to HPE booth or Ampere booth to look at demo of the RL300. Stefan will be attending the OCP Summit during the whole week. If you have specific end user questions, do not hesitate to ask him. Thank you very much.
Yeah, thank you very much. Thank you, Stefan, for coming.
Thank you.